Hey guys, Matthew Palumbo here, Director of Training for Stinger and Audio Control. And on today's workshop, we're going to talk about the good, the bad, and the ugly of LOCs, or line output converters. So without further ado, let's jump right in. So when it comes to getting signal from a factory sound system and using it with aftermarket components like amplifiers, speakers, and subwoofers to make a system sound better, how are we getting that signal? For years and years, this was a common answer, the passive line output converter. And still to this day, I go into stereo shops all the time and I talk with techs and salespeople that go, hey, we use these things all the time. They work fine. What's wrong with that? Well, plenty. Back in the day, you used to be able to get away with that because sound systems were simpler. The signal was more basic and full range in most cases. These days, that is not the case. Most of the vehicles on the road today do not have a flat, clean signal that you can just tap into. It's much more complicated than that. And that's why we're going to dive into what are the different LOCs, which one do I need and why, and how do we use these, and what does the signal actually look like? So let's take a look. So when it comes to obtaining signal from a factory stereo system and turning it into a great sounding aftermarket stereo system, things aren't like they used to be. We used to be able to just use these basic plastic, inexpensive little passive line output converters, and they were commonplace, right? We all use them in the install bay. And I still see shops that use those things on a daily basis, and they don't always understand why they should use something else. They figure, hey, especially if I'm just adding bass, why do I need to use a premium active line output converter? And on the screen right now is our Pro Series family of line output converters from Audio Control, and you can see we've got a wide selection of these things for all sorts of different jobs, whether we're just adding bass, whether we need something that fixes bass roll off with AccuBass. Maybe I have a vehicle that has no bass at all, which we'll dive into later, or maybe I'm doing a multi-channel system where I need signal summing and AccuBass and all of these things, right? Well, that's all good and fine, but why do I need to use these? What's the good, the bad, and the ugly? Why am I using this over that basic, inexpensive little LOC that, hey, let's face it, we've used for years. Lots of shops keep them still stocked on the shelves and use them every day. So here's a little explanation of kind of what makes these things special, right? What makes them different? If you don't know anything about load selection or load matching circuitry or LGDs, well, you've got another thing coming. If you've never worked on a vehicle that had a problem with outputting sound once you disconnected the factory speakers, once that factory radio or amplifier no longer saw a load, an impedance load from those factory speakers, a lot of them will stop putting out sound. Our Pro Series of LOCs have a circuit built in called LMC, which matches that impedance load and tricks the factory radio into still putting out sound. Not only that, if you've tried to find a remote turn-on signal or a switched 12-volt signal in a vehicle, a late model car or truck, a lot of times it's very difficult. It's not like it used to be where you could just tap off the cigarette lighter or tap off the fuse block. That can be a complicated and sometimes, damaging process in a lot of vehicles. So again, we built in some great turn-on modes that help assist with that and make sure that you're getting a reliable way to trigger your system every time they fire it up. What about noise? We've all dealt with noise. We've all had a integration system go wrong, right? We've all tapped signal off of a factory system, fed it into some sort of converter, and at the end of the day, we had turn on pop and turn off pop and whine and buzz and alternator noise. Well, that's what ground isolation switches are for. That's why we have these built into nearly all of our products, but especially the Pro Series of LOCs. On top of that, we have some extra features built in that are great for the installer. Things like a maximized light, which helps you to set up the system and optimize it in the signal chain. This makes sure we're not overdriving the inputs of the amplifier, we're not overdriving the outputs of the factory system, or setting gains too high. It's a kind of like a check engine light or a dummy light for system setup. Same thing with AccuBass. AccuBass now has an LED indicator, making it easier to set up than ever. If you aren't familiar with AccuBass, well, let me show you something. In recent years, and this has been going on for quite some time, we've had vehicles that actually turn down the bass as you drive or as you turn up the volume, depending on the vehicle. I've even seen convertibles that actually turn down the bass when you put down the top. This way, as the owner of the vehicle turns up the volume in their convertible, they're not going to hear the bass anyway, the OEM figures. So, hey, let's turn it down a little bit so that they don't blow their speakers. Not a terrible idea, except for when you're trying to upgrade that system with aftermarket components and really make it rock. So how does AccuBass work? What does it do? What am I talking about with bass roll-off or bass plateau? What we're talking about is when an OEM actually plateaus the bass. So the example I like to use is, let's say the volume on your factory radio goes from 0 to 100. And maybe at volume 60, the bass stays there. So we turned our radio up, mids and highs, we hit volume 60, the bass stays there, but when I go from 60 to 100, the mids and highs keep going up in volume, but the bass stays at 60. That's a bass plateau, or bass roll-off, as a lot of people like to call it. So how do we fix that? Now, some shops just tell their customer, hey, volume 60 is your max, that's all there is to it. But what if volume 60 kind of sucks? What if volume 60 isn't that loud? What are you going to do? Ride the gains on all your amplifiers to compensate? Not a great solution. AccuBass is the fix. So how does AccuBass work? As the vehicle's moving, as they're turning up their volume, what happens is the bass actually is turned down by the factory processing, right? This is where AccuBass comes in. AccuBass fills in that gap from volume 60 to volume 100 in my example, so that bass and treble, or mids and highs, all move consistently up the volume chain as they increase their volume on the factory system. That's what AccuBass does. It fills in that gap, and when set up correctly, it works exceptionally well. It's like the bass roll-off or plateau was never there. So why an active LOC? Why are we not using these cheap, basic little plastic boxes that everybody's been using for years? What you may or may not know is what this actually does to your signal. So I'm going to show you. If this is your OEM radio signal, and this was done using a Toyota Tacoma factory radio, I did this myself using the DMRTA test tool. And what I did is I just played pink noise through that factory radio and then just measured the results with different converters and tools. So straight out of the factory radio, this is what it's putting out. Some of you may or may not be surprised to see that this is not a flat signal by any stretch of the imagination. It's relatively flat in that all the frequencies are there, but you can see it's got a pretty heavy peak there in about 250 to 300 hertz range. So this system has not a lot of highs, not a lot of lows, but a fair amount of mid. That's how they've EQ'd it. Now keep in mind, the bass, treble, balance, and fader controls on this radio were all set to 0. Just keep that in mind. So this should be relatively flat. This is what you get out of that factory system. Now, what if we pass that signal through a passive LOC? Again, we're still getting the same signal, but you can see it's not quite the same, right? There's now a new peak. There's a different peak. You'll notice that although it does pass full range signal, it degrades the low frequency. And how often does everyone install these? Just to add an amp and sub. That's where I see it the most commonly is, hey, we're just putting in a bass package anyway. Well, let's not spend the money and put in this expensive, quote unquote, active LOC. Well, it's up to you. Do you want the full potential of your system, or do you want, a degraded signal that really only gives you a partial amount of what they paid for? Most customers want what they paid for, right? They heard it in a demo car or in your store. They want that experience. And if you're putting in one of these, you're not giving them that experience. You're just not. So when you look at the signal from the passive LOC, you can see the bass is definitely degraded. Why? Because a passive line output converter can't do it. It just can't. It cannot pass signal through it unmessed with, right? It is manipulating the signal as it goes through that device because it's passing through little, resistors and caps and coils, et cetera, inside there. It is basically passively, manually converting that signal. But all it's really doing is taking in the signal from the radio, dumbing it down, and then spitting it out. Yes, it physically converted it from speaker wire to RCA, but really all you've done is physically changed the connector and dumbed down the signal. And unfortunately, in the process, you lost a lot of bass for your customer. Now, when you look at this signal through an LC2i Pro, first thing some of you are going to notice is, hey, where'd all the highs go? Keep in mind, on an LC2i Pro, there is a bass output and a main output. The bass output is cut off crossover-wise at about 1,000 hertz. So that's why you'll notice everything on the highs here is definitely got a pretty steep slope. That's intentional. What we're mostly focused on today is the bass side. Remember, in this example, we're adding a bass package. So if we used an LC2i Pro, you can see right off the bat, the signal is hotter because all of the little blue bars are a little bit taller, meaning you have more amplitude or voltage. Also, you'll see that the bass is definitely not degraded. It's a much hotter signal, but we didn't degrade the factory signal at all. We're just passing it through at this point because we haven't engaged AccuBass. Now, when we switch to the LC2i Pro with AccuBass, look how much fuller that low end is. Look at what that signal looks like now. Now we have a full, robust, hard-hitting low end that we can feed out to any amplifier and sub package and have a great result. Now your customer is getting what they paid for. Now your customer is getting what they wanted when they stepped foot into your store. This is what they came for, right? Is hard-hitting, punchy, feel it in the seat of your pants low end. This is what they want. Give it to them. Sell them the proper active LOC and hook them up with what they actually need. Even if you're on a budget and they only have so many dollars to work with, I would rather use a less expensive amp, sub, and box, but include an active LOC, rather than blowing my whole budget on a nicer amp and sub, but not having the dollars left over and having to put one of these in. You're not doing them any favors. And honestly, you're not doing yourself any favors, because this is your reputation we're talking about. When they go talk to their buddy and show off their system and let them hear it, and what they hear is a system that doesn't sound great, especially not at all volume levels, your name's attached to it. You're the one that sold it and you're the one that installed it. Is that what you want out there? I don't think so. So that alone that you just saw should be enough to convince you that, hey, active LOC is the way to go. If you didn't believe me before, hopefully seeing it on an RTA, an actual electrical RTA, by the way. That was not a microphone. That was actually connected straight to the speaker wire outputs or the electrical signal, and that's what I was showing you. So hopefully that alone was enough to convince you, but if it's not, let's take a look at the frequency response, and maybe this will change your mind. All right, so here we are on frequency response. Remember, we already looked at kind of what we're doing to the overall signal, but here's a summary of it. When we look at this, now you can see all four outputs together. So I've got them all compiled for you in one place. These are the four screens you just saw. So when we look at this, we can see, look at that OEM radio signal to begin with. Fairly flat, but got a kind of mid-range peakiness to it. Not a lot in the low end. We go to a passive LOC in the bottom left corner there. Okay, we still have all of our signal, but now the frequency response has changed and it's not quite the same signal. It'll work, but it's not going to be great. We added an LC2i Pro, we've got a much more robust signal, and now it's a little bit hotter, and then we add in AccuBass, and it all just comes together. So next on the list, let's talk voltage. This is something that a lot of guys don't pay that much attention to, but is absolutely critical to having a high performance system. If you are feeding in a weak factory signal or a weak line out signal into your amplifiers, then the whole system's gonna be weak. There's a reason that all of those aftermarket premium radios from all of the big manufacturers have a high voltage RCA output. In the past, we even saw outputs as high as 8 volts from some manufacturers. These days, we're seeing 4 to 6 volts is pretty average, and that's a very clean, solid signal. But what are you getting when you just take the factory radio signal and feed it into something, right? So in this case, the OEM radio is only putting out about 18 watts per channel, not super strong, right? So why not just use an inexpensive passive LOC? It's not that it's a super high power signal. And that's a common mistake I see a lot of guys make is, well, hey, the factory radio isn't a high wattage system. It's not a premium amplified system. So I can get away with just using a basic, cheap passive LOC, right? Wrong. Yes, will it work? Well, technically it'll turn on and make noise, but is that really doing your customer any favors? Definitely not. So in this case, we feed that same signal into a passive LOC like we've been talking about. And what do we get? At max unclipped volume from that radio, we're getting 1.3 volts. Let that sink in for a second. 1.3 volts is what you're getting out of a passive LOC. That is the same signal you get from a bargain basement flea market swap meet radio, okay? That's essentially what you're giving your customer if you're putting in a basic passive LOC. Lame. That's not what they came to you for, right? If they wanted that, they would have went to the swap meet. If we're talking about high performance audio, we want a clean, healthy signal, and that's what we're gonna get from an active LOC. Now, of course, us being us, I'm going to show you audio control, but an LC2i Pro with that same signal fed into it at that same max unclipped volume from the factory radio is giving us a little over 6 volts of usable, hot, clean signal to go into our amplifiers. What does this all mean? Why do we care about having a high voltage signal, right? What this means is we can turn down our gains. If we have a high voltage signal coming in, we can keep our gains down, and we're actually going to have more output, less distortion, less clipping or potential for clipping, more, headroom. You're going to just have a better experience, and the customer is going to have a better sounding system and a better sounding car, and that's going to turn into repeat business for you. All good things come from high voltage RCA line outputs. So the last thing we're going to look at really on the LOC side is clipping and distortion. What does the signal look like? And for those of you that have never used an oscilloscope, this is what it looks like. This is the signal fed in electrically into the oscope and analyzed. So what we're doing is this is the factory radio turned up to max volume, okay? Now what you're seeing there at the very top is a basically square wave. This is pure clipping and distortion. This is what we don't want. This is horrible. Okay, we're playing a 40 hertz test tone. We're measuring that signal, and with the volume up all the way, this is what they get when they turn up that radio. This is how customers blow speakers. Now with the passive LOC, same thing. We're trying to find out what point does this radio not clip? At what point do I have a clean signal? On this radio, the volume went up to 60. It turns out 38 out of 60 was where the factory radio had a clean output signal, okay? So a clean signal is going to look like a nice smooth rolling wave. A clipped, distorted signal is going to be square, jagged edges, and it doesn't even have to be as dramatic as the top one there. If you're analyzing an O-scope, it could even be as simple as the signal kind of shark finning and leaning over. But in this case, when we look at the signal that was clean and undistorted out of the radio, fed through a passive LOC, look at that middle photo. Look at what that passive, cheap little converter is doing to that signal. It is making it into practically a square wave. That is not a good signal. That is clipped and distorted and going to sound nasty, okay? It is going to be clearly audible to the naked ear. You are going to hear that distortion and clipping. Now, when you look at the LC2i Pro, same signal, same volume level, volume 38 out of 60 on that radio. We are getting a clean, unblemished, untarnished signal that is hot and has lots of voltage that we can feed into an amp and just have a great sounding system. Okay, so we've talked about the signal from the radio, what it looks like through a basic, cheap, passive LOC, and what it looks like fed through a high-quality LOC, right? So now we should understand the basics and understand why we need to be using these. I know it's a big jump for some shops to go from selling basic little $20 LOCs to selling, more expensive products that are more premium, but you and your customer are getting a better system out of the deal. And for the installer, it's an easier job. They're not trying to fight that signal. They're not trying to fight all of those installer challenges that come with using basic, bargain, cheap product that was never really designed to do what you're using it for. You use a premium product, you get a premium result, okay? Now, what about the vehicles that those products can't fix? If you remember earlier, I talked about some cars that just have no bass at all. I call these permanent high-pass vehicles. What this is if you haven't experienced this yet, I promise you're going to, and most of you probably have. If you ever had a car come into the install bay that just had no bass at all, you tapped into every signal in the vehicle, you tried multiple LOCs, both passive and active, you tried different amplifiers, different subwoofers, different enclosures, and no matter what, you just couldn't get any bass out of this car. This may have been why. So I started to see this years ago, and I've been training on it ever since because I want to spread awareness. And I don't know what else to call these other than permanently high-passed vehicles, because that's literally what they are. The OEM manufacturer has decided that, hey, this car is never going to reproduce 30 hertz anyway. So at any volume. So why even let it play it at low volume? Let's just cut it off. Customer's never going to know. Cars got little, 4 little 5.25 or 6.5 inch speakers anyway. What's the difference? So they high pass it built into the factory radio, and all is well on their end. But when you try to add an aftermarket system to that vehicle, you're going to notice, trust me. The first one I ever saw it in was the image on the left, the 2018 Honda Accord. Now, this was a base model vehicle. We're talking the commuter edition, like basic of the base models. But in that vehicle, had a big old touchscreen, had factory CarPlay, Android Auto, backup camera, satellite radio, all the things most customers are going to want. What it didn't have was any bass. You literally took a look at the signal coming out of that factory radio. It was just 4 sets of speaker wire, basic stuff. You take a look at that signal and you'll notice there's no bass. And this is at any volume, on any source, at any speed, there is no bass. So how do you fix this, right? Now, that Accord is one example. I also saw it in a Nissan Sentra with my own eyes. You can see not only does this one have no bass, but it also just has a crazy factory EQ curve. So these are things to watch out for. How do we fix this? What do we do to fix this? There's no T harness for these vehicles. There's no preamp solution because they're not amplified cars anyway. Like, how are we going to go about this? Here's what we do. We use an epicenter. Yes, the epicenter. I know, you're rolling your eyes, right? You've heard of the epicenter, you've seen it a million times, you've sold it a bunch, you've installed a bunch of them over the years, and traditionally people use them to compensate for music that doesn't have a lot of bass. And that's a great use for it. But what about using it to compensate for a vehicle that has no bass? This is why we invented products like the Epicenter Micro Pro, because we need something that has OEM integration features, high-level inputs, load matching circuitry, built-in line driver, so on and so forth. But how does it actually do what it does? Well, this is how it does it. The Epicenter actually recreates bass that wasn't there in the first place. It's actually looking at the harmonics of the music, and it is adding in bass below the lowest current frequencies. So if you are working on one of these cars that doesn't have any bass information, any signal in the path below, say, 50, 60, 70 hertz, well, the Epicenter would fill in those gaps and fill in everything below the lowest frequencies that the car currently reproduces. So this is why products like the Epicenter Micro and the latest Epicenter Micro Pro, my personal choice, is out there. This is what they're for, is to fix this problem. And they do it very, very well. It doesn't have to have anything to do with their taste in music or their preference. It can just be about the vehicle. So stop thinking about epicenters as, hey, I sell them to a certain type of customer that listens to a certain type of music. Yes, they're great for that too. But what about the customer that just has a vehicle that needs one? That's really where you're going to see these smaller platform epicenters come into play. So hopefully you learned something in today's workshop. I hope you have a better understanding of why we really do need to be using an active LOC, and you learned a little about the good, the bad, and the ugly of getting signal from an OEM radio and sending it through a line output converter. For more information on audio control or PAC or any of Stinger's products, be sure to check out audiocontrol.com, pac-audio.com, or stingersolutions.com for our whole family of products. I'm Matthew Palumbo from Stinger and Audio Control. Thanks so much for watching, and we'll see you on the next one.